And welcome to the next PLGBC expert webinar. Today we'll be talking about carbon footprint with One Click LCA. Um, with us is Carolina, expert with One Click LCA. So we have a long presentation and full of information about today's topic. So I think, Carolina, you could start. Please share your presentation now.
Yes. Okay. Um, Thank you, Magda, for the introduction. Hi, everyone. My name is Carolina Aitokallio. I am a business developer in One Click LCA, and I have a background as an architect and urban planner. Today, we'll be talking about integrating the carbon footprint of buildings into your workflow. And for this, I will share with you this presentation, and we will have also a short demo of one of our tools that can help you also with this, especially in the early design assessment. So yeah, at first, we're going to start with a short introduction on One Click LCA. Then we'll talk about the lifecycle assessment process that and we can use to calculate the carbon footprint of our buildings. Then we'll also talk about how you can differentiate yourselves by optimizing the embodied carbon in early design phases. And then we will talk also about how to evaluate different design options during the early stages and carbon footprint and lifecycle assessment also, what is the difference between them with the help of One Click LCA. So about One Click LCA, our mission is to power the makers of a zero carbon future. We are the world's leading construction and manufacturing LCA software. We have solutions in terms of software for building LCA, infrastructure LCA, manufacturing LCA, which is also for product LCA. So if a manufacturer would like to issue environmental product declarations with the help of One Click LCA, they can do it. And also for corporate greenhouse gas reporting. We are present in over 130 countries worldwide. Very happy that Poland is one of those. We can offer all global data, so all the publicly available EPDs are integrated in our database, and we can also integrate with more than 15 different types of software. We are a Finnish company based here in Helsinki with over 20 years of existence and more than 100 people in our staff. We are able to connect the entire industry through our tools. So, for example, manufacturers, they would come to us asking for help on how to do the calculations for their EPDs, as I mentioned earlier. Their EPDs will then be used by architects and engineers when making the life cycle assessment calculations or carbon footprint calculations also for their projects, and also for making more informed decisions to make the specifications of materials for their projects. Builders, investors, and institutions also use our tools, mainly for purposes of portfolios, for example, ESG, or also for obtaining certifications. So all of these companies that you can see here, they are all our customers. And in Poland, we are very happy to be trusted by many companies as well as the ones that you are able to see here. So moving forward, we are able to help our customers to improve at every project phase. And one thing that we have in mind all the time, and we must have in mind, is that as the project stages move forward, our decarbonization potential of the project will halve as each stage moves forward. So for this reason, it's very important that we act in the early stages, because the early stages are the stage that will help us in the sense of we can make the changes, and we still have all our options open to define. To sum up, we are a global platform that offers data and tools for compliance globally. At the top, you can see some of the databases integrated in our software, and at the bottom, some of the certifications. For both of those, we have much more also as well. With this, we make carbon easier to understand and to act on, and we produce our results not only in numeric tables, but also in a series of different graphs that can help our customers to also explain their decisions to their customers as well and justify them. Okay, so now let's talk a little bit about the process of the life cycle assessment and how it can help you with obtaining the calculations for your carbon footprint. So the process of life cycle assessment, why is it so important? The global building stock will double in 40 years. And this is because the construction industry is the one that is the most responsible for the carbon emissions as of today in the world. This means that if we keep building at the speed that we are today, we'll be building something like a New York City every month for the next 40 years. And with these, of course, we know that the impacts that it will cause, it's something that we are not ready or able to mitigate. So for this, we need to act now, and instead of producing the impacts, we need to, or how to mitigate them, we need to focus on minimizing them. So the life cycle assessment process is a way in which we can break down the processes within the construction industry and help us understand how are we contributing with our choices for these emissions, and how can we also contribute in minimizing them. So the life cycle assessment process, it starts with the A phase, which is the product stage or the material stage. And this is the stage in which we will consider from the extraction of the raw material to the transportation of the manufacturing site and the manufacturing process of the material, as well as the transportation to the construction site and then the installation of that material in the building. Then we will jump to the B phase, and in the B phase we have the use stage. In the use stage, we are going to account for the use, maintenance, repair, and replacement of this material. Here we can also account for the operational carbon, in which we are going to account for the use of water and energy as well. Just one more thing to add in the A phase, which is very important. That's when we talk about the embodied carbon, which is the carbon emissions coming from the materials. And in the B phase, we talk about the operational carbon. Then we have the end of life stage, which is the C stage. And that is usually after 50 or 60 years, depending on the methodology that is being used or the regulation that is being used to make the assessment. And in the C stage, the end of life, we will see the processes of deconstruction and demolition, transportation to the waste handling facility, then the processing of the waste and disposal as well. And apart from these, there's also one more module that will come after the C, which is the D stage. And in the D stage, we have something very interesting also, because in the D stage, we can account for the benefits and loads beyond the system boundary. So this means that if we do anything like reusing, recovering, recycling, we can, with the materials that we had, we can actually offset the carbon that we were emitting from the previous stages. So this helps us in a positive way for our calculations. Now, let's also talk about how you can differentiate yourselves by optimizing embodied carbon in early design phases. So, as I mentioned earlier, early decisions have the highest impact. And this is because in the earlier stages, the material stages, we still can change the design. We can still change the materials. Those decisions have not yet been set in stone so that we can develop all the other areas of the project. So this is where, in the early stage, the decisions that we have the most impact, and where we can also have the most influence on the project's emissions. So here you can just have an idea, for example, of where the early stage is, in the sense of also what are the tools that we would be using when we're talking about it. Today, we will have a look at the Carbon Designer 3D, which is a tool for the very early stage before the concept design, when we would be using, for example, parametric modeling tools, and very much before the detailed design. So this is where our focus will be today. And also, another very important reason of why early decisions have the highest impact, it's because they have the lowest cost. So when we are still working in this strategy phase, that we still have our decisions, the project hours, they are still being used for the project. We can still manage everything. Our bill of materials have not yet been done. Our purchasings of the material have not yet started. But as the project moves forward, all of these processes, they start to be set in motion. So this, of course, also generates costs to this operation. And how are you going to differentiate from others? So let's break this down into 5 steps so that we can have a clear picture of it. First off, we need to find the opportunity to provide highly relevant and highly valuable advice in this strategy phase. That is, you can try to find the way in which realizing a life cycle assessment would help your customer the most. And also, you need to choose in which direction you want to implement the changes. So, are you going to implement the changes in your project, in some part of the building? Are you going to implement your changes in the types of the materials that you are going to specify? Or are you going to focus on reducing the costs and so on? So you need to also set this strategy in motion and define the scope for it. Then, okay, we have the idea of what we would like to do and how we would like to do so. Let's now create a good enough baseline so that we can work with it and have a starting point to our decision-making process. This is step number 3. Step number 4 will be comparing different design options before committing to a design. So if you are uncertain if a certain shape of a project, for example, that would have you spend more material than another, but would be greener material, how would that work with a shape that would be a bit different, maybe simpler, but with more materials that are more conventional and probably have most emissions. So you can compare, for example, the options when it comes to the quantities and what materials you would be using. Then finally, step 5, you will choose the best design option for your purpose before drawing a single line. So this is possible to do, and we will see it today. So let's also now think about what are the benefits of early design LCA in your projects. If you perform early design LCA in your projects, you can minimize the environmental impacts and innovate in your offering, because this is not something that is yet being offered and taken as something that is mandatory, but it will be. So it's very good to take the advantage to start doing it now, because when the time comes when it will be mandatory to do LCAs, then you are already ahead of your competitors. And why am I saying that this will be mandatory? Because in other places, it already is mandatory. There are countries in which we cannot build a building without also providing the life cycle assessment results of that building when we get the building permit. And there are already projects of law to set this in place in all over Europe. So this is the starting point. There is already outside of Europe as well. This is already happening. But if we take this right now as a way to incorporate life cycle assessment in our offering, when the time comes that it will be mandatory to do it, we will have already everything set in motion. It's also a benefit to evaluate products' efficiency and quality, because this will help you to make more informed choices. And another way that lifecycle assessment can help when it comes to choosing the products is you can see, for example, products that are more efficient and they have more quality. They can also help your customers in other ways. For example, if you have really good insulation, then probably their electricity bills are not going to be as high than if you wouldn't have such a good insulation in the project, for example. Also, it influences manufacturers to improve in their products. One of the great driving factors for manufacturers to improve in their products and focus more on eco-design is that their customers, architects, engineers, builders, they all are looking for greener products. They all are looking for more transparent products because this also helps them in their projects. So this is a chain that goes in motion in which if the manufacturer's customers are interested in a greener product, then they will also have to improve their products, and it will also help to innovate their products, and they will have better offerings also to you. And finally, this is what we're talking about today, but of course there are more benefits beyond these. You can also combine it with life cycle costing and have more sustainable projects for both environmental and financial perspectives. So you can translate your results not only in emissions, but also in monetary figures. So then you can use it also as a tool to show to your customers the costs of their projects. And of course, there are other benefits beyond these, but I think that for today, these are the ones that would be really good to share with you. And we can talk about it more also in another opportunity. So speaking of opportunity, providing life cycle assessment as a business for your customers, it can be a business opportunity that would add a lot through high value advice with a marginal investment cost, because we have tools that basically for this purpose of early stage LCA2, it would be a fixed cost that you can do for multiple projects. Okay, so let's now evaluate different design options during the early stages. So what should you be paying attention to when you are doing an assessment for the early stages? First, we need to evaluate the building needs. We need to evaluate the early planning, which is the most important part. So we need to think to design with long-term need and usability. Think about energy efficiency and the source of it as well. We need to think also in the design phase about the design being flexible so that it can serve multiple purposes, for example. Also that the materials are long lasting, and I will tell you a little bit more of the reason for this in a moment. Need to obviously think of material choices and also about, in the construction phase, the construction site and transport. But the main focus would be in the early planning and design. When we talk about the material use for the design, we need to also think about the building itself. So when it comes to the site and how the building will be inserted in the building site, it's always better to use materials above ground, because then you will avoid services such as moving earth masses or designing and building a wall containment. So all of these, they would generate more emissions than if the building was set on top of the ground. Also, focusing on building for people, so limit the material that will be used for cars or other types of vehicles or other purposes as well, unless it's extremely necessary. Then we would have the shape efficiency as well, in which if you would have a more compact design mass, you would be also avoiding to use more material. So this is also something to have in mind. When it comes to the service life, and this is what I said I would be mentioning as well, we need to think of materials that will last as long as possible. And why is this? Because as we saw in the life cycle stages, we have at first the manufacturing stage, the A1, and all products will be considered the manufacturing stage. But if the building has, let's say, a lifetime of 60 years, and we have a material that will cover this lifetime of 60 years, then we will only have the manufacturing stage and then the demolition stage and the use stage for only once. But let's say the material lasts 40 years. So we will have the manufacturing stage, then we will have the demolition stage, and then a new manufacturing stage so that the product is replaced, and then again another demolition stage. So we will be doubling our impacts here. If the material will last 25 years, we would be tripling our impacts, as we would be having two replacements. So it's very important to think of using materials that would last long. Avoid the replacement. Then we can also evaluate the material for the supplier sourcing. It's possible to benchmark the material with different suppliers and see the impacts of different suppliers as well. And this is very good and important also because you keep your options open, and you can also have your decisions being justified by, for example, a supplier that has a material of better quality, better performance. And of course, compare the materials as much as you can. So we have here the advanced material comparison that compares the materials with both their emissions from the life cycle stages to also their financial cost and the financial cost and carbon cost put together. So this is also a great way to find the materials that you would like to work with. And not only this, but also to justify the choices of the materials that you would be specifying to the project. So now we will have a look at the carbon footprint and life cycle assessment with the help of One Click LCA. What is the difference between carbon footprint and the life cycle assessment? Well, the life cycle assessment, it is first of all the methodology in which we can be either calculating the carbon footprint as a result, but also what we call full LCA is a way to conduct the life cycle assessment and having more results from different impact categories than only global warming and biogenic carbon storage, which is the case of the carbon footprint. So in the full LCA, we have also different types of indicators. For example, we have ozone depletion potential, acidification, eutrophication, formation of ozone of lower atmosphere, and so on. So these impacts, they are not only going to measure global warming, but they are also going to measure other indicators that are important, as environmental important as well. So, for example, the possibility of the material contributing for example, acid rain, or also for growing more seaweed as well. So we have here also other ways to measure our impacts as well, which are as important. And also with One Click LCA, you can measure, let me just go back to talk about it. With One Click LCA, you can measure both the carbon footprint and the life cycle assessment, the full LCA as well. So to start, we can create the baseline using minimum data. And what would be this minimum data? The gross floor area, the country region where the project is located, the type of the building, and also the number of floors. So once we do the input of this data, we can also choose the regional model of the building. So we have different regions that we account for, because different regions, they have different constructive patterns. So we also take this into accountability, and we have the reference building that we would be working with. And this reference building is something that we are always working on it and making it as close as possible to different regions. So after we do the input of the minimum data, we will also see other optional choices. So we will define the assessment scope. What are the parts of the buildings that would be included in the assessment? We will also do the input if there would be any underground floors that can be heated or unheated. We will also see the soil conditions and the structural solution. So we would be defining also what is the type of frame that we would like our building to have. Will it be concrete, concrete in situ, precast concrete, steel, load-bearing walls, also timber. So we can see these possibilities. Then we would be using different templates. So the different templates, how do they work? To create a template, you would need to basically inform what are the materials you would like to use for each part of the building. So you can have multiple templates. For example, you can have an office template. So every time you want to do an early stage assessment of an office, you would know that for the office, I want to have this material for foundation, that material for floors, the other material for windows. So you can just choose and assign the materials according to your planning of that template. So you can have like multiple templates for multiple types of buildings, or as you wish to do. So these templates, they are previously made choices of the materials in our database that will be applied to your building when you are conducting an early design assessment. So with this, you are able to compare different options before you draw a single line. So right now, what I will do is we will go to One Click LCA, and then we will see how this tool would work. So here I have a project that I created for our meeting today. And in here, we will now click on the Carbon Designer 3D tool, which is the tool that I was just referring to, is the early design assessment tool. And if I click here in Levels Lifecycle Carbon or Levels Lifecycle Assessment, I will be working with the tool of my choice. The Levels Lifecycle Carbon is a tool that will give you the results for carbon footprint, because it only gives the results in global warming and biogenic carbon, and the Levels Lifecycle Assessment gives you the result with other impact categories as well. Both of them can be used for the purpose of the European taxonomy, and they are in line with the EN 15978, which is the European norm for life cycle assessment. So let's just click here in one of them. And here we can create a design. So let's create a design. I will name it Polish GBC webinar. And here we have our reference building. So here we have many different options depending on where the building is located. Then we have the gross floor area. So we have here 3,000 square meters, which is the size of the building. When I created this project, I did the input of what would be the size of my building, and I chose 3,000 square meters. And the calculation period, we can add here 60 years. Then we can move forward, and we have here an office building, for example. We can choose other different types of buildings, for example, sports halls, school, social, any kind of other building as well. So apartment building and so on. I will proceed with the office building for the purpose of this exercise. Then we have here the scope. So this is where we'll be choosing our building parts that will be a part of this assessment. So here we have foundations, ground slab, structure, enclosure, finishes, and services. You can tick or untick them as you would like to perform your assessment. The number of above ground floors. So here I can decide the number of floors. I can put, for example, 6 floors, and number of underground heated floors or unheated floors. So we can also add them here. Then, but I would just say I'm not going to add anyone here, any number here, because also this is one of the points that we talked about earlier, that we should design above the ground. So here, when we are talking about the structure, we have different choices. So for example, we have here the timber frame or concrete and steel. So you can choose one of them to proceed, and then the piling length for visualization. So here I can put some meters for the piling length for visualization. And if you have any other special elements that you would like to add to the foundation, you can add them here as well, like the second piling wall or the soil stabilization. So then we can move forward, and this is our building with our 6 floors. And here we can see the building dimensions. And in these dimensions, we can also edit them. Let's say here I want like 22 or 20. I can edit them as I wish. Then we have here also all the other dimensions, but once we are happy with it, we can click here to calculate the areas. Once we have the area, so we have here the possibility also of editing the areas if we would like to. And after we are happy with it, we can proceed. And this is where we would be assigning a template for our building. So here I have some templates, and I could assign them, one of them, to our building. If not, it's okay. The software will make the choices for you, and you can always edit them as well. So here I will submit. without choosing a template, and I will let the software make the changes for me. And this would be the stage in which the software will be choosing the materials and assigning them from our database to this building based on the information that I have inputted during this process in the Carbon Designer 3D. So once we have the results, we'll be able to evaluate where we can locate the most emissions in this design. Okay. So here we have our results by elements. So we see that here, for example, the floor slabs, they have really high results, and external walls as well. So, well, it's very good to see this information here because we can act on it, but we can also see it in the model if I activate the carbon view. So we see here that our walls and slabs, they are red because not the ground slab, but the floor slabs. They are red because this is where we have the most emissions. We can see these results also by material, by classification and total. As we see here, for example, also 505 kilos of CO2 per square meter. And then we have also here the list of all the chosen materials, and we can edit this list as well. We can either edit it by share of like square meter or percentage with also other materials. And let's say we would like to compare this design with other designs. So we can just come here and choose another design or create another design. Let's say now we would like to have another, let me just go back to add here the 60 years. We would like to have another building with office as well, everything the same. So I can add here my 6 floors and my piling length. But now instead of concrete, what if we try timber? So then we have again our new building. We can calculate our areas and then go through the process again. This way we will be able to compare two different types of options of design for our project. And then we can also choose with which one we would like to move forward. So as we can see here, just by changing the type of frame, we are able to reduce almost 100 kilos of CO2 per square meter. Our first building had 505 kilos, and now we have 408 kilos. Basically, the emissions here also, they shift a little bit in our second design. The external walls, they are not that much responsible for the emissions, but the floor slabs still are, as in the same project. Sorry, as in the same for the first design that we did for this project. So, okay, let's say we are ready to move forward, and let's say we will be choosing the second option here. So let's move forward with it and save the design to our project. So I already have a design here named baseline, and I have no data on it, but if I had, I can either override the data or merge with existing data. So here it will be the same for me. And once I save all the materials that have been in this design here, in this list, they will automatically be here transferred to my building materials tab. So here I have my building materials. And here I can also add more materials either manually. For example, if I type here ready mix concrete, and I can also see the list of materials here to choose from. For example, if there are some materials that they have a manufacturer specific, so I can click on the question mark, I can download the EPD and see more information in depth, and then I can also go a bit more in depth, and I can select some materials to compare and make that comparison. For example, here I'm selecting some at random, just so that we see the functionality. So I can click here and add to compare, and then we can compare the data here. The materials that I've selected, the different types of concrete, also by cost, and we can also see the numeric results, and these will help to make the most informed decisions when it comes also to the materials. Finally, we can have a look at the results. So here we have the results for carbon footprint. So we see only global warming and biogenic carbon storage, but we see it through all the life cycle stages. And here we see also the D phase with the negative value helping in this calculation. And we have some functionalities also that would help in the terms of the project. So here we have, for example, the overall grade B of the project. So a few things we would need to just adapt with manually. And we have a threshold value, which is a reference value, for example, of like what is usual in this kind of project. And we can compare with ours and also improve on it. Then we have also the list of the most contributing materials. So here we have, for example, the cross-laminated timber is the most contributing material here. And it has this light green cloud here, which means that it is a material with a good kind of emission, but not the best kind of emissions. But if we have this one here, for example, for the floor, this one, it has a very green cloud, so it means there is a really good material in terms of emissions. So for this cross-laminated timber here, which represents 30% of our building, which is made with timber, I could click here and show sustainable alternatives, and then I can see here a list of options from a ranking in which we can benchmark also the suppliers. And I can, for example, see if I would like to substitute my selected product for one of them. So I can also benchmark my product choices like this. I can also add it to the comparison feature that we just saw as well from here. And then we have our graphs. So we have the basic graphs, the pie, bar, column, and tree map graphs, and the advanced graphs, the bubble, Sankey diagram, tree map, life cycle stages, annual, spidergram, and so on. So these would be the results for the carbon footprint. And if we would like to look at it from the perspective of the full life cycle assessment, here we have the both tools. So they are considering the same information for the same design. I can just go straight away to the results, and I can see here all the other impact categories and their results as well. So I can see, as I mentioned earlier, the ozone depletion, acidification, eutrophication, and so on. And also the uses of primary energy and water and the site impacts. So we can also do here the input for the construction site operations as well. And again, our graphs, but now focusing on the full LCA results. Here in the beginning of the project, we have on the top left side, the embodied carbon benchmark, which is a tool that compares your project with projects in similar projects. For example, if it would be offices, then it would compare with offices in the same location. So here we have Poland, and then it grades it in comparison with the other projects. So here we have grade B, which is an okay grade, not the best in terms of emissions, so this can be improved as well. And then we have also the embodied carbon by life cycle stage that shows us which life cycle stage is the one responsible for the most emissions. In this case, we have here the A1 to A3, the materials with 66%, which is usually the case that the materials is the stage that is the most responsible for the emissions. But here we have also a huge part of this pie graph with the replacement phase as well. So this is also something that can be a strategy here to focus on the replacement. Then we have the embodied carbon by structure, which accounts also for what are the most the structures that are responsible for the most emissions in the materials stage. And here we can see that they are the horizontal structures and vertical structures as well. So this also can give us some guidance in the changes that can be done in the project for future improvements as the project moves along. So with these being said, I would like now to thank you for watching until now, and I would also like to open the floor for any questions that you may have.
Thank you, Carolina. Yes, we have one question on chat. Two questions on chat. First of all is from Carolina too. Carolina asking about the similar tool with One Click LCA for deep modernization of an existing buildings.
Yes, it's possible to do it with our tools. Basically, what you would be doing is when you would be doing the input of the materials, if you would be reusing a material, maybe I can show you this here, which is easier to see. So basically, of the materials of the existing building, the materials that you would be still reusing, you can tick here in reused material, and then it will disconsider the A1 to A3 phase because it was for the building when it was built and not for the building that you would be working with now. And also, when it comes to any demolition that you would be doing, you can come here to construction site operations, and you can account for it here. So you would be accounting these demolitions with the here the waste generated on site. So then you can choose here the type of waste that it would be. So in this case, it would be probably the other waste. and then you can choose here which would be the one and how you want to account for it. So for example, if you want to just account it for it generally, you can have like construction waste to landfill, and you can account for the quantity of it. So just one thing, do not account for it in the construction demolition, because this is for the C1 stage, which is the end of life of the building that you will be accounting for, right? And if you account for it here, this will be for the installation phase, so for the A5 phase, which is where it should be. So yes. And the other question?
Yes, the second one is from Yaroslav. How we can see the result without defining the type of facade?
Yes, so for the facade, in this case, the facade would be defined by the typical building reference. So it would not be anything special. So if you would be doing some different type of facade, what I would recommend is that when you are going through the assessment, then let's just have a look here, which is easier to do. So I would just go here just so we have a look quickly on this. So here we have, for example, the enclosure. So you can exclude it here from your assessment, and then you can add it separately if you would have some kind of special facade. Then you could do it like this. Otherwise, it would be just a typical kind of facade, nothing really special.
Okay, we have one more question. Well, it's asking about the situation when there is no when couldn't find some material EPD on one-click tool, and what is the step to have when I can find a specific EPDs. So the similar EPD when the main is
Yes.
can find on.
So there are locations in the world in which not many manufacturers are investing in doing EPDs. And for these locations, we have a way to help, and that is through our generic database of EPDs. We also have our localization, manufacturing localization method that basically allows you to use EPDs from neighboring countries as if they had been produced locally. But if for some reason there is an EPD from a manufacturer that exists, it has been issued and is published, and if it's not in the database, it is of One Click LCA, it is probably because it did not pass our quality test, because before we integrate the EPD, we go with a quality test over it, and then if it gets approved, it gets integrated in the database. Another option would be also to use the tool for the private materials library, and then you could do the inclusion of that EPD for your account only.
Okay, the next question is from Noemi. What is the source for the threshold values in LCA checker? For example, year, country. Are those representative of the building type in certain country?
Yes, so the source of the threshold values, they come from the typical reference building. So it would be typical according to that type of building, yes. I'm not sure about the year of or country specifically, but I can definitely look into it and I can get back to you with this information in more detail.
Okay, and I think is the last question. on chat? Yeah. No, not the last one. We have one more from Rafał. Going back to the facet, are we excluding enclosure in both or just design?
You would be excluding it in the baseline, but you can add it manually, for example. So when I said you can exclude it here, but you can also add the materials for the facade manually if the facade is something that is very special. Otherwise, if it would be considered at first as a common type of facade, like typical facade, then there's no need to exclude it. You can just keep it.
Okay, the next one. Do you have any recommendation on what typical building life span should be used for EU taxonomy purpose? Do you have an auto recommendation?
Yeah, so Rafał already answered for me there.
Yep.
And that's totally correct. 60 or 60, okay. 50 years usually, yes.
Okay, we have only 2 minutes to finish our meeting. So is this the last question or not? Waiting, I think, a minute about next one. I think the last one is the last. So thank you, Carolina, for this meeting, for this webinar. Thank you for answer of the question. And I think it's done.
All right. Thank you. Thank you, Magda, for organizing the webinar. And thank you, everyone that attended it. It was a pleasure. And if you have any other questions, I'm available to answer them later on via email.
Great. And see you soon. Bye.
All right. See you. Bye-bye.